Today I want to go over two more examples for how to calculate Ka and then two examples of how to calculate pH of a weak acid. So first one, we are given an initial concentration of our weak acid and we're given the pH and we need to solve for Ka. Alright, so first thing I can do is write my reaction. So the weak acid is going to dissociate. We know acids are going to donate a proton, so I'm going to pull off a hydrogen. And then we can start by filling out our rice table. So the initial concentration of the acid is 0.25 molar. Initial concentration of my products is going to be 0. Concentration of the reactants will decrease. Concentration of the products will increase. Alright, once we have our rice table filled out, we want to solve for X. X is equal to the hydrogen ion concentration. So if I can solve for H+, I could solve for X. Well, I'm given the pH, so I know that 10 to the negative pH will be equal to concentration of H+. So the pH is 4.65. 10 to the negative 4.65 gives me 2.2 times 10 to the negative 5th. So that's the concentration of H+, and again, that is also going to equal X. Once we have X, we can figure out the rest of our concentrations. So the concentration of our conjugate base is equal to X, so its concentration is also 2.2 times 10 to the negative 5th. Alright, for our acid, its concentration at equilibrium is going to be equal to 0.25 minus X. But since X is so small, it's going to be negligible, so I'm going to leave X out. Alright, once we have all of our concentrations, we can now write an equilibrium expression and solve for Ka. So Ka is going to be equal to the concentration of the products over reactants. And all I have to do is plug in my values and solve. And again, I'm just going to use the initial concentration of my weak acid. I'm going to assume that X is negligible. And when we solve, I should get 1.9 times 10 to the negative 9th. Alright, just to make sure that X actually was negligible, remember we can always think about that 5% rule. So we can take X divided by the initial concentration of that weak acid and multiply by 100. As long as that number is less than 5%, X is going to be negligible. So X equals 2.2 times 10 to the negative 5th. The initial concentration of my weak acid was 0.25. Multiply by 100 to get that in decimal form. Very, very, very small number. So since my percent is less than 5x is negligible, so we don't even have to worry about subtracting x from that initial concentration. All right, next example. Calculate the Ka of a 0.2 aqueous solution propionic acid with a pH of 4.88. All right, so again, the acid will dissociate. And acids are going to donate a proton. So I'm just going to pull a hydrogen off. Protons are positive, hydrogen has a charge of +1, so the conjugate base will have a charge of -1. The initial concentration of my acid is 0.20. Always going to assume the initial concentration of our products will be 0. Reactants decrease in concentration. Products increase in concentration. Once we have our rice table filled out, next step is to solve for x. And again, x is going to be equal to the concentration of H+. So again, we can use our equation. Concentration of those hydrogen ions is going to be equal to 10 to the negative pH. And this is also going to be equal to x. So the pH in the problem is given. It is 4.88. So x is equal to 1.32 times 10 to the negative fifth. So concentration of the conjugate base is equal to x. So its concentration is also 1.32 times 10 to the negative fifth. And again, we are going to assume that x is negligible. So for my weak acid, I'm just going to plug in the initial concentration. We can check to make sure that it is negligible because now I know what x is. Again, we're going to do x divided by the concentration of the weak acid and multiply by 100. Since my percent is less than 5%, we can assume that x is negligible. All right, lastly, we need to solve for Ka. Ka will be equal to products over reactants. And then all we have to do is plug in our values and solve. Ka equals 8.7 times 10 to the negative 10th. All right, next two problems are going to be the reverse. So for these two, you were given pH and you were solving for Ka. Now you're going to be given Ka and we're going to be solving for the pH. So weak acids, again, partially dissociate. Acids donate a proton, so we can pull off one of those acidic hydrogens. Initial concentration, 0.35 molar. Alright, next step is to solve for X. So for the previous problems, we used the pH to solve for the concentration of hydrogen ions. We don't have the pH. So what we want to do is write a Ka expression and then work backwards to solve for X. And we can plug in what we know. The Ka is given to us in the problem, 6.3 times 10 to the negative fifth. For my products, I'm going to have X times X, which is X squared, over my reactant. And again, I'm going to assume that X is negligible to avoid the quadratic formula. So now we can solve for X. So I can start by multiplying both sides by 0.35. And then to solve for X, take the square root of both sides. 4.7 times 10 to the negative third is equal to X. Again, we can make sure that follows the 5% rule by taking X, dividing by the concentration of our acid, and multiplying by 100. We would get 1.3%. Since it's less than 5, X is negligible. So now that we have X, we can find the pH. X is equal to the concentration of H+. So X is equal to the concentration of H+, so we can now use our pH equation. pH is equal to the negative log of H+. So pH is equal to the negative log of 4.7 times 10 to the negative third. About 2.33 would be my pH. Last one more problem where we are solving for pH. So for this first step where we're doing the reaction, all that I'm doing is pulling off one of those acidic hydrogens. The initial concentration is given. This is a 0.100 molar solution. Concentration of the reactants will always decrease. Concentration of the products will increase. So we have the Ka. So what we can do is write a Ka expression, work backwards to solve for X. So both of my products are X. So Ka is going to be equal to X squared, multiplying our two products together, over 0.100. And again, I'm going to assume that X is negligible. First step is to multiply both sides by 0.100. And then to solve for X, we need to take the square root. So 5.9 times 10 to the negative fifth is equal to X. So again, quick check with our 5% rule. I'm going to take X over the concentration of our weak acid, multiply by 100. If your number is less than 5%, X is going to be negligible. So again, since it's less than 5%, we could ignore the minus X. We don't have to use the quadratic formula to solve for this. Just leave your denominator as 0.100 rather than 0.100 minus X. Looking back up at our Rice table, X is equal to H+. So the concentration of hydrogen is equal to 5.9 times 10 to the negative fifth. Once we know the concentration of the hydrogen ions, we can calculate pH. pH is equal to the negative log of H+. And when you calculate this, I got 4.23. Hope that helps. Let me know if you guys have any questions. Email me. Keep working on the Mastering Chemistry, and keep up the good work.